Part 6: The Forest's Time Machine. How forests predict the future without knowing it. This gives you a bigger progression. Connection, threat recovery, signals, memory, foresight. And that's a huge idea, because it lets you answer the next question your audience will naturally ask. If forests can signal and remember, do they also anticipate? Scientifically, the answer must be framed carefully. Not prediction in a conscious human sense, but anticipatory responses, seasonal timing, risk-sensitive adaptation, and evolved preparation. That's where the script gets powerful and credible. Part 6: The Forest's Time Machine. How forests predict the future without knowing it. What if the forest has a way to prepare for the future without ever seeing it? Not prophecy, not planning, not intention in the human sense. Something older, something slower, something more reliable. Timing. This is Part 6, The Forest's Time Machine. And if Part 5 showed us that forests remember the past, this chapter asks the next impossible question. How does a forest use time itself to survive what comes next? Because forests do not live only in the present moment. They live in cycles. Light cycles, rain cycles, temperature cycles, seasonal cycles, disturbance cycles, growth cycles, dormancy cycles. To us, these can feel like background conditions. To a forest, they are survival information. A forest cannot run from drought. It cannot migrate overnight. It cannot send a rescue request when heat arrives early, so it survives by doing something else. It tunes itself to patterns, bud burst, leaf out timing, flowering, seed production, dormancy, root growth pulses, water use strategies, chemical defense timing. These are not random events. They are tightly linked to environmental cues: day length, temperature, moisture, chilling periods, and local climate patterns. In other words, the forest survives not by knowing the future exactly, but by being exquisitely sensitive to the signals that usually come before it. That distinction matters, because this is where science is strongest. Forests do not predict like a human analyst. They do not imagine scenarios, but through evolution, physiology, and ecological feedbacks, they can express something that looks astonishingly similar: anticipation through patterned response. Take seasonal timing. Many trees use photoperiod day length as a stable cue. Why? Because day length is predictable, while temperature can be noisy. In many systems, plants combine photoperiod with temperature and moisture cues to regulate growth and dormancy timing. That combination is brilliant. It reduces false alarms. A few warm days in late winter should not always trigger full leaf out. A temporary cool spell in spring should not erase the entire season. The system balances responsiveness with restraint, and that balance is everything. Respond too early, and a late frost can destroy new tissue. Respond too late, and the tree may lose growth opportunities, reproductive timing, or competitive advantage. This is not just biology, this is risk management. The forest is constantly navigating trade-offs between speed and safety. And so are we. Now look below ground. Root growth, microbial activity, and fungal interactions also pulse through time, often tracking temperature, moisture, carbon availability, and seasonal shifts in plant metabolism. So when the visible forest appears still, the underground system may be accelerating, slowing, storing, reallocating, or waiting. Waiting is important. Human systems often treat waiting as failure. Forests treat waiting as strategy. Dormancy is not inactivity, it is controlled suspension. A way to preserve function through predictable adversity. A way to avoid spending energy at the wrong time. A way to survive winter, drought, stress, or low resource periods without collapsing the whole system. That may be one of the most underrated lessons in resilience. Not every pause is weakness. Sometimes a pause is what keeps the system alive long enough to adapt. But now the story gets harder. Because the forest's time machine works best when the future still resembles the past. And in a rapidly changing climate, that assumption is under pressure. Seasonal cues can become mismatched. Warmer temperatures may arrive earlier. Frost risk may still remain. Pollinators and flowering times may drift out of sync. Drought timing may shift. Fire seasons may lengthen. Pest dynamics may change. Heat extremes may arrive outside historical norms. This is called phenological mismatch in many contexts when timing relationships between organisms and environmental events begin to decouple. And it is one of the most important stress tests of ecological resilience in the modern world. Because now the question is no longer just, can the forest prepare? It becomes, can the forest update its timing fast enough? Some species can adjust more than others. Some populations show plasticity. Some systems retain enough diversity to absorb mismatch. Some cross thresholds. Again, the science matters here. There is no single forest answer. There are only patterns, probabilities, constraints, and adaptation pathways. And that makes the story more powerful, not less, because the forest is not a fairy tale of guaranteed balance. It is a real system under real pressure, trying to stay synchronized with a moving world. So what does a forest do when timing becomes unreliable? It falls back on the same deep strengths we've been uncovering across this series: signals, memory, diversity, redundancy, distributed response, recovery pathways. If one timing strategy fails, another may still function. If one species declines, another may carry part of the role. If one season damages growth, stored reserves may support survival. If one patch is hit, another patch may regenerate and reseed. This is why biodiversity is not just beauty, it is temporal insurance. Different species operate on different clocks. Different genotypes respond to cues differently. Different life histories spread risk across time. A monoculture may look efficient in a stable year, but in an unstable decade, it can become a synchronized failure. The forest avoids that by refusing to put all of time on one schedule. That line matters for every human system too, because one hidden form of fragility is time fragility. When your organization depends on everything happening on time, in sequence, with no delay, under stable conditions, that is not resilience. That is choreography without contingency. Now zoom out, because this is where the forest becomes a blueprint for future-ready design. In cybersecurity, we patch after attacks. The forest asks, how are you tracking timing patterns before the breach? What normal rhythms define healthy? What anomalies show up before visible compromise? In supply chains, we react to shortages. The forest asks, what seasonal patterns, lead time drift, and weak timing signals were already visible? Where are your reserves? Where are your alternate pathways? Which dependencies fail together? In organizations, we celebrate speed. The forest asks, do you know when to slow down? Do you have dormancy modes? Do teams have protected recovery periods? Can your system survive timing shocks without burning out its core tissue? In cities, we build for average conditions. The forest builds for cycles and survives by adjusting to variability. That may be the next major lesson in resilience. Strong systems do not just store memory. They develop timing intelligence. They know when to grow, when to defend, when to conserve, when to reconnect, when to wait, when to act fast. And above all, they avoid mistaking one season for the whole future. This is why forests can feel ancient and adaptive at the same time. They are shaped by long memory, but they live through repeated updates. Every spring is a test. Every drought is a test. Every disturbance is a test. Every recovery is a test of timing, not just strength. And if you watch carefully, the forest keeps teaching the same lesson. Survival is not just about power. It is about synchronization. With climate, with resources, with risk, with relationships, with the changing pace of the world. The systems that last are not always the fastest. They are the ones that can change tempo without losing coherence. So, what should we learn from the forest's time machine? Build systems that understand time, track patterns, not just events, protect seasonal capacity, not just peak output, design fallback modes for low resource periods, diversify timing dependencies, train for delays, not just targets, preserve reserves, study mismatches, and never assume that what worked last year will work unchanged next year. Because when the pace of the world shifts, timing becomes destiny. Not fixed destiny, but operational destiny. And the systems that survive will be the ones that notice the shift and retune before the break. If Part 3 was the recovery code, Part 4 the signal layer, and Part 5 the memory system, then Part 6 is the next layer, the time machine. Not prediction through certainty, but foresight through patterns, preparation through timing, resilience through rhythm. And once you see that, you start seeing time differently everywhere. In forests, in markets, in infrastructure, in teams, in families, in your own life. The strongest systems are not the ones that move fastest, they are the ones that know when to move. If this changed how you see forests, timing, and resilience, like this video and subscribe to Hidden Nature Science TV and QeoshTV, because the next lesson from the forest may not be about strength at all but about rhythm.